So on Earth's surface, the gravitational field strength is 9.81, but this is asking us, when will it be 7.33? So that needs to be farther away from Earth, right? So like I was saying, like it needs to be out of the atmosphere. So this is going to be a little ways away. So what I am looking for is R. That's my question mark. Now I'm going to be specific here. What I'm looking for is the distance away from Earth. So I'm going to specify that I'm looking for RD. I'm just going to say that distance away from Earth is equal to RD. I'm told what my gravitational field strength is, or acceleration due to gravity. At this point, it's saying it's 7.33 meters per second squared. So I'm going to use, and I know, so really, if I drew this, here's my mass 2. This is Earth. And it's telling me what point out here in space is my gravitational field strength 7.33. So I'm going to use the formula G is equal to big G times M2 over R squared. Now, well, I'll tell you later in a little bit. So let's rearrange that to solve for R. So if I'm rearranging to solve for R, I'm going to put R on the top fraction, so I just cross multiply my fraction. I want to solve for R, so I get rid of little g, and I can square root. So R now is equal to the square root of g times m2 divided by small g. So now you can plug that in. Now remember, have your data booklet with you at all times so that you can kind of flip and see what's going on here. So big G is 6.67 times 10 to the negative 11 multiplied by Earth's mass. So my M2 is ME, and that's on your data sheet too. That's 5.97 times 10 to the 24 kilograms. This is all divided by 7.33 meters per second squared, and that value needs to be squared.
What is that value?
Oh, thank you, sorry. You're right. It's just meters per second squared. Yeah. Hi. Yep. These should be good. Okay, so when you plug that in, you should get R. Oops, I picked up the wrong thing. R is equal to 7.3705, etc., times 10 to the power of 6 meters. But this is my R total. Okay? So look at my diagram. What I just found out is the total distance from inside, like the center of that object, which is Earth, all the way to the point. So I found RT. I would say that's R total. I wanted to just find this distance right here. And I said that's RD. Well, how do I find RT? Or RE, I guess. Radius of Earth, data booklet. So now to find RD, it's equal to RT minus the radius of Earth. So the radius of Earth is 6.37 times 10 to the 6 meters. So when you put this in, you should get 1.00 times 10 to the 6 meters.
Why do you assume that it's the whole distance? Do you always assume that it can be?
Yes, yeah, so these equations, this equation refers to the center of one object to the other object. Yes. Mhm. So when you're calculating it, you're always assuming that if you're with a planet or Earth, that it's from the center.